All right, we're almost done with the study guide. We have 4 proofs. 3 are on this page, 1 is on the back. Don't forget to do number 28. All right, number 25, just to kind of get you started, I wrote in some statements and I want you to just think about what makes them true. So let's look over here first. Let's not even look at this stuff yet. We're asked to prove that angle 1 is congruent to angle 7. And we're told that these 2 lines are parallel, and we can see that's marked in our diagram. So we know that angles 1 and 7 are alternate exterior angles. So honestly, this could be a 2-line proof, but that's not what we have here. So as we kind of work through this, we know this first statement is true because that's what's given. So we know that always comes first. So the next statement is that angle 1 is congruent to angle 5. So if we look on this, how do we know those are congruent? Well, what type of angles are they? They're corresponding angles. You cannot write corresponding angles as your reason. That's not a reason. That's a definition of a vocab term. The reason is the corresponding angles postulate. And if you were to say theorem, I'm okay with that too. So corresponding angles postulate / theorem. And you could abbreviate that as CIP or CIT, or you could just write it out. Or you could say when these lines are parallel, corresponding angles are congruent. That just seems like more work because it's the most writing. All right, so from that statement, the next statement someone said, all right, 1 and 5 are congruent. 5 and 7 are also congruent. So what allows 5 to be congruent to 7? Well, they're vertical angles, right? So we could say the vertical angles theorem. Vertical angles theorem. So now, to jump to the conclusion that 1 is congruent to 7, if 1's congruent to 5 and 5's congruent to 7, for us to conclude that 1 is congruent to 7, that's an illustration of the transitive property. And that right there is a proof of that's called the proof of the alternate interior angles theorem. We proved that our alternate interior angles are congruent. All right, let's look at 26. This one looks a little scarier because we don't have these statements to help us. But it's not scary at all. It says complete the following proof without using the converse of the alternate exterior angles theorem. So when I look, I see 1 and 8 are alternate exterior angles. The converse of that tells me that if these are congruent, these lines are parallel, but I'm not allowed to use that particular converse. So I've got to find another one. All right, so our given statement is that 1 and 8 are congruent. And I just need to come up with like some other congruency that must be true here. All right, so if 1 is congruent to 8, if I look at this like intersection down here, I know 5 has to be congruent to 8 because these are vertical angles. And I don't know that P and R are parallel yet. So I can't go like from 8 to 4, for example, but I can say that 5 and 8 are congruent because they're vertical angles. And I'm just going to write this in my brainstorming space over here. I'm going to write that for vertical angles theorem. And so now if I know that 8's congruent to 5 and 8's congruent to 1, 1 and 5 have to be congruent. And if I think about that, they're corresponding angles. So if they're congruent, I could use the converse of the corresponding angles postulate to prove that these lines are parallel. So let's do it that way. There's other ways you could do this one. Well, there's other ways you could do any of them, really. All right, angle 1 is congruent to angle 8, and we said that that is our given statement. From there, I could use any pair of vertical angles. So I could go from 1 to 4 or 5 to 8, and I just happen to write down 8 and 5. So I could say that angle 5 is congruent to angle 8, and that is because they're vertical angles, the vertical angles theorem. I'm going to write that for vertical angles theorem. I would also accept like definition of, I would also accept all vertical angles are congruent because they are always, every time. All right, just like we use the transitive property in the one above, if I'm making a logical argument and I say, hey, angles 1 and 8 are the same, but angle 5 is also the same as 8, we can conclude that 1 and 5 are the same if they're both whatever angle 8 is. That's called the transitive property. I'm okay if you say, hey, that looks like substitution to me. That's fine. But the statement that lets us say angle 1 is congruent to angle 5, I could either think of this as I substitute this in here for 8, or substitute this there for 8. Really, I think that's best illustrated by the transitive property of congruence. Transitive property. All right, now line 4. We really just need to say one more thing about this. This is enough right here to prove these lines are parallel. But the reason, we got to think about why. Well, you just told me, you didn't tell me anything, this is a video, but we just discussed that angles 1 and 5 are congruent. They're corresponding angles. So the thing that tells us that if corresponding angles are congruent, then these lines are parallel, is the converse of the corresponding angles postulate. And I could abbreviate that CCAP, the converse. All right, we got one more on this page, and I think I'm going to try to do that last proof on this page also. Number 27, prove that the measure of angle 8 equals 80, given that 1 is congruent to 6. I'm going to mark those right away. And measure of angle 1 equals 80. And these lines are parallel. That really should be in our given statement, but whatever. I'm not going to freak out about it now, but that should have been given to us up here. We can see it on our diagram though. All right, so we know that the measure of angle 1 is 80 degrees. And if 1 and 6 are the same, the measure of angle 6 has to be 80 degrees. We're trying to prove that the measure of angle 8 is 80 degrees. Well, 6 and 8 are what type of angles? Vertical angles. I hope you answered out loud with the video. So we know that angle 8's got to be 80 because angle 6 and angle 8 are vertical. All right, so let's think about how we could set this up. For our statements, we know we got to start with our given. This should never be blank because I can always copy down something that is written as a given. All right, the reasoning or reasons or justifications is that is given. All right, so from there, I might even say, so 1 and 6 are congruent. And then I might just jump down here and say angle 6 is congruent to angle 8. And the reason for that is they're vertical angles. So I'm going to use the vertical angles theorem. So then if I know the measure of angle 1 is 80, the measure of angle 6 has to be 80. So I could say the measure of angle 6 is 80 degrees. And if I think about why that is, there's a few ways we could justify it, but if we look up here, well, we said 1 and 8 are congruent. We said what 1 is. We know 6 has to have the same measure. I think there's a lot of ways you could justify it. To me, that is the very definition of congruence, that things that are congruent have the same measure. So I'm going to cite the definition of congruence. I think there are other ways you could justify that. To me, that's what that is. And then lastly, if measure of angle 6 is 80, then the measure of angle 8 would also be 80. Again, because they're congruent. So to me, and someone might disagree with me, but to me, that's the definition of congruence. I'm just going to write the congruent symbol. All right, there are other ways you could do this. This is by no means the only way, but I think, I don't know, that's how it spoke to me just now when we did it. All right, let's see if I can get this last one on this video so we don't have to watch one more video. Oh man. All right, prove that angle 2 and 7 are supplementary given that L is congruent to N. So L is congruent to N. I want to get to the fact that 2 and 7 are supplementary. You know what? We could really do this in one line. I think typically I'd want you to say a little more, but just because I'm tired of doing proofs, and I think you are too. Let's just illustrate how this is actually super easy. All right, so for our statements, we've got that L is parallel to N. The reason for that is it is given to us. So that's our reason. Can't believe I put this one on the study guide. It's so easy. All right, so if L is parallel to N, we ask ourselves, first of all, how are 2 and 7 related? 2 and 7 are same side exterior angles. And there is a theorem that says that when these lines are parallel, our same side exterior angles are supplementary. So we are not gonna, there's other ways we could do this, much longer ways, but I could jump to this and say angle 2 and angle 7 are supplementary. And that's because they're same side exterior angles, and that's because of the same side exterior angles theorem. Bam, we're done. All right, good luck.